turn up the difficulty a touch here on these problems. So this example is a little bit more involved, so let's go through it. So it says a truck with a mass M has a brake failure while going down an icy mountain road on a constant downward slope of alpha. Initially, the truck is moving downhill at a speed v naught. After careening downhill a distance L with negligible friction, the truck driver steers the runaway vehicle onto a runaway truck ramp of constant upward slope beta. The truck ramp has a soft sand surface for which the coefficient of rolling friction is mu sub r. What is the distance that the truck moves up the ramp before coming to a halt? Solve using energy methods. Okay. So originally my truck is moving at some speed v naught. It careens down a distance L, then heads up the truck ramp at an angle beta, a distance, I'm just going to call it S here, with a coefficient of friction of mu r. So my truck is starting at one point over here and ending at another point over here. Now I have labeled the heights. I'm going to call this one height 1 and this one height 2 when I talk about potential energy. And so now I just need to list out that work kinetic energy theorem. Whew, that was fast. All right, so we're going to do what we usually do, where we cross out anything that's going to be 0. So work in, well, no one is pushing on the truck, okay? There is friction during this S distance. So yes, there's friction, but not for the whole thing, only for our distance S here. It comes to a rest at the end. There is kinetic energy at the start because it has that initial V naught speed. And it does have height at the end. I'm going to call that H2. It does have height at the start. I'm going to call that H1. And there are no springs in this problem. So let's see if we can figure this out. So in order to deal with H2 and H1, in terms of the variable we're given and the variable we're looking for, we will have to do a little bit of effort here, in that H1 is going to be L times the sine of alpha, and H2 is going to be S times the sine of beta. All right, so work done by friction, we'll remember, is the force of friction vector times the displacement over which it occurs, and in our case that is just S. All right, and then I have negative 1/2 mv naught squared plus mgh2 minus mgh1. All right. So for that force of friction, we do need to start making our substitutions. This is a kinetic type friction, so it's a constant rolling friction value for us here. So this is going to be negative mu sub r times the normal force times S. All right. So I do have to solve for that normal force. So I will come down here, resolve mg into components. So I have an mg cosine of theta. So when I sum up the forces in this y direction, perpendicular to my surface, I see that normal force equals mg cosine theta. All right, so now I have negative mu sub r times mg cosine theta times S is equal to negative 1/2 m v naught squared plus mgh2, which is S sine beta, minus mgh1, which is L sine alpha. All right, so at this point we have some stuff we can cross out. So every term has an m, fantastic. Okay, all the terms have a g except for this one. So I'm going to go ahead and divide everything by g here. Get rid of that. And then the last thing I'm going to do is I'm going to, I guess I could leave it. Yeah, let's get rid of all the minus signs here. So let's multiply everything by a -1. Okay. All right. So we've condensed a touch here. I want to get all of my S's on the same side. So I have an S here and an S here, so I need those two terms on the same side. So I'm going to go ahead and take this negative S sine beta and move it over to this side. Okay, so now I have S times the sine of beta plus mu sub r cosine, oh, it's not theta though, what was it? Beta over here. Oops. Beta times S equals, and here I have V naught squared over 2G plus L sine alpha. So I'm just solving for S, so I'm going to have to factor it out and divide that over. So I'm going to factor out that S, so I have sine beta plus mu sub r cosine beta equals that, divide it over, so now I have S is equal to V naught divided by 2, V naught squared divided by 2G plus L sine alpha, all divided by sine beta plus mu sub r cosine beta. Now, notice they didn't give us any values here. So we are just solving this with the variables they gave us. Now, an important step here is because we're getting closer to that AP test, we need to make sure we have all the values here. So in other words, I got to make sure I don't have any like psi or H1 or H2 or something like that that's not a variable that I was given, like normal force, for instance. So I made sure and I substituted out all of those variables that weren't talked about in the problem. And it'll typically say solve in terms of, this one doesn't say that, but it's kind of implied. So there's that one. Looks like we have another example problem next.